of projectiles, lesson number 1. So I'm continuing with that. I'm going to now start with example 4. So let's have a look at example 4 in your notes. So in example 4, we've got a missile, just an object thrown through the air, and it's projected from A at 25 meters per second and lands at B as shown. Find the time of flight, the time it takes to go from A to B, and find the height of B above the ground. I'll look at the last part then when I've finished that. So here's the situation. So I'm throwing it from A, which is already 3 meters above the ground, and it's going to be caught by someone at B. And I've got to find the time of flight to go from A to B, and the height of B, that height there, above the ground. So I'm going to draw up a table as usual. This is a table for B where it lands, where it's caught. So what have I got? I've got UX. UX is, well, first of all, UX and UY will both be positive. So if I take X, right is positive, up is positive. So they'll both be positive. So UX is 25 cos 30 degrees. So put that into your calculator. If I put that into my calculator, I'll get 25 root 3 on 2. I can divide the 2 into the 25 if I want, because it gives me a nice decimal. So 12.5 root 3 meters per second. Divided to UY. UY, of course, is 25 sine 30 degrees. Put that into my calculator, and it'll give me 25 halves, which is 12.5 meters per second. So let me put those entries into my table. So this is 12.5 root 3 and 12.5. We know, of course, that the acceleration in the x direction is always 0 when we do these horizontal planes. And the acceleration due to gravity in the vertical direction is minus g, or minus 9.8 meters per second squared. To find the s's, let me put the coordinates in. And as usual, we always start, don't we? We always start at the origin. So this is where we start. So A is the origin, so that'll be 0, 0. So we'll take everything relative to A at the origin. And what's B in relation to that? Well, B will be, how far do I go across from A? I go plus 30. Then how far do I go up at that point? I don't know. So let me just call that SY, the distance in the Y direction. So I can fit in that entry. And SY, I'm going to leave blank. So look, if you look at the left-hand side of that table, I've got full information. That sounds like a good place to start. So I've got 2 equations all the time. And the 2 equations we always use are S equals UT plus a half AT squared, and V is equal to U plus AT. We apply them separately in the X direction and the Y direction. They're perpendicular to each other, so neither has an impact on the other. So let me write down I'm going to start, as I said, this entry on the left-hand side. So I've got S equals UT plus a half AT squared. I'm going to apply that in the X direction. And of course, you know, don't you, that AX is 0. So that last term disappears, which makes it very handy. So now I've just got SX is equal to UXT. So what's SX? 30 is equal to UX, 12.5 root 3. Multiplied by time. But now I can calculate the time of flight to go from A to B, which is the very first part of what they're asking me. So T is equal to 30 divided by 12.5 root 3. Let me put that into my calculator. And I get 4 root 3 on 5. You can leave that in third form if you want. Turn it into a decimal. Let me turn it into a decimal. So I get 1.385, say 1.4 seconds. So the time of flight is 1.4 seconds. That time, of course, is shared between both sides of the table, the x direction and the y direction. Time has no dimensions in the x and y directions. So now I want to find Sy. Now remember, Sy is going to be the height above the origin. They're asking me for the height above the ground, so don't forget to add on at the very end that 3 there. That's got to be added on. So let me write down my formula for S equals ut plus a half at squared. And I'm going to apply that now in the y direction, where there is acceleration due to gravity. Sy is equal to uy, which is 12.5, time of flight, 1.4 seconds, plus a half ay. Well, you know that well now, don't you? Half of that number is minus 4.9. Minus 4.9, t squared, 1.4 squared. So now I put all that into my calculator, and that will give me the distance of B above the origin. And I get an answer, let's say, of, to one decimal place, 7.9 meters. And therefore my answer of the height of B above the ground, don't forget to add on the 3. So it's going to be 3 plus the 7.9 is the distance above the origin, and that gives me a distance of 10.9 meters above the ground. Let me now look at the last part of this question. It says find the maximum height above the ground. So in other words, you're going to take the highest point in that trajectory and you're going to work out the maximum height of that above the ground. So let's say the maximum height looks to be about there in my diagram. So I'll call that maximum height, let's say, capital H. I suppose the one thing you do know, don't you, when it does reach its maximum height, what do I know? I know that its speed in the y direction has to be 0. It's no longer going up or down. So Vy is equal to 0. And that means I'm going to use my other formula, V is equal to U plus AT. And I'm going to apply that in the y direction. What about my table? Well, let me call this point here, say, C. So now I'm going to do a table for C. The thing about your table is the first 2 entries will always be the same. The initial speeds will be the same, and of course AX and AY are always the same, but these will change. Now we're talking about the coordinates of that point C. Well, how far did I go out? Don't know. How far did I go up? Well, that's what I've got to find. So those 2 entries are now blank. And what we've got to do is we've got to find Sy here, and that will give me the maximum height above the origin. And don't forget to add on the 3 to get the maximum height above the ground. Well, I'm going to use this formula to find the time it takes to reach the maximum height. So as we said, at the maximum height, Vy is equal to 0. Uy is 12.5. Ay is minus 9.8. T. So I'm going to find the time it takes to reach the maximum height. So that's going to be equal to 12.5 divided by 9.8. I'm not doing all the algebra with you, you know, we're higher level applied maths, so a lot of your algebra will be assumed when we do this. So 12.5 divided by 9.8, and that gives me a time of, let's say, 1.28 seconds. I'll go to 2 decimal places because it's not really my final answer. And now I want to find the distance in the y direction. So I'm writing down s equals ut plus a half at squared. How high does it go after a time of 1.28 seconds? We're applying that in the y direction. So sy is equal to ui 12.5 by time 1.28 plus a half ay, you know what that is, minus 4.9 by t squared 1.28 squared. So throw all that into my calculator and that will give me the distance of the maximum height above the origin in the y direction. And I get, say, 7.97. That's approximately 8 meters. And therefore my answer will be, for the maximum height, it's going to be the 3 meters there. The origin is 3 meters above the ground, plus the 8 meters above the origin, giving me a maximum height of 11 meters above the ground. Moving on to example 5. So a missile is fired from the ground with a speed of 25 meters per second at an angle of 60 degrees to the horizontal. Find the range and maximum height of the missile. Right, here's a situation where we're going to fire a missile off level ground and it's going to land on the same level ground. We're going to prove some formulae for this in the second lesson in projectiles. Anyway, let's have a look at example 5 in detail. So there's my situation. Once again, wherever you start, call this the origin. So this will be 0, 0. The range is the distance it travels horizontally along the ground. So this distance here from launch to landing, that's called the range, which we call r. What are the coordinates of the point where it lands? What do I call this point? I call this point O. How far did I go across? Well, I went across a distance called the range, or Sx. Doesn't matter if you want to write down Sx there or R for range. Let me write down Sx. And what is the y coordinate? Well, if it lands at the same level from which it's launched, that means its y coordinate is 0. So let me put down a table here, a table for point A. What's ux and uy? Well, ux is 25 cos 60. Put that into your calculator and you get 25 halves, which is 12.5 meters per second. And what's ui? ui is 25 sine 60 degrees into my calculator, and I get 25 root 3 on 2, and that will give me 12.5 root 3 meters per second. Let me put those entries in here. Ux is 12.5 and uy is 12.5 root 3. And what about ax and ay? They're always the same, aren't they? In these problems, 0 and minus 9.8. And what about Sx? You could call Sx the range, the horizontal distance it travels along the ground. And Sy is 0. My first inclination here is I have full information on the right-hand side of the table, the y part, and that's where I will start. They want me to find the range. Well, before I can find the range, I must find the time of flight, the time it takes to land. You'll always need that time to do any of these problems. So let me get rid of this. So as I said, I'm going to start here on the right-hand side. I'm going to start with s equals ut plus a half a t squared. And I'm going to apply that in the y direction. Sy is 0 is equal to Uy, which is 12.5 root 3, multiplied by time t, plus a half Ay, that's minus 4.9 t squared. So I've got a slightly different quadratic equation for time that I had before. There's no constant here. I could divide across by t. It's always dangerous to divide across by variables. Or I could take the t out in common. And one of the answers will be t is equal to 0. T is equal to 0 makes sense. In other words, after 0 seconds, it was at a height of 0 meters above the ground. But that's what I would call a trivial answer. So if you want divide across by t, as long as you know what you're doing. If I divide across by t and jump that across, I get 4.9 divided by t, and that t squared becomes t, and that is equal to 12.5 root 3, and that t is gone. So therefore I can solve for t, so that implies t is 12.5 root 3 divided by 4.9. So that will give me the time of flight to go from launch to landing. So let's say I get 4.42 seconds. Now I'm in a position to work out the range by going to the other part of the table. I'm going to write down my S formula in the x direction. But of course, you know this, don't you? That last term is not required because AX is 0. So SX is the range, and that's equal to UX. And UX is 12.5 by the time of 4.42 seconds. And that will give me a range of 55.25 meters. That's the first part done, the range. The next part, they're asking me to find the maximum height. So let me go into my diagram for the maximum height. Well, if I fires off level ground and it lands on the same level ground, that there is a perfectly symmetric parabola. And the maximum height is actually halfway along. We'll see this later when we do some of the proofs. What time does it take to reach the maximum height? Well, you can prove this later by putting Vy is equal to 0. But to reach the maximum height, it takes half the time of flight. So when we're talking about the maximum height, I can use this. I can say, and this only applies, by the way, in this type of situation where you fires off level ground and it lands at the same level. So this is where it only applies. So the time to reach the maximum height is half of that time there, 2.21 seconds. But you can prove that if you want. How would you prove that? Put Vy equal to 0, because that's where the maximum height occurs, and solve for time. And when you solve for time, what do you get? You will get 2.21 seconds. Try it if you want. So here's the maximum height. Let's call this point here point B. So now I want a different table. I want a table now for B. Well, the first two entries are the same, but the last entry, the SX and the SY, they've now changed. In other words, the coordinates of that point B are different. What are the coordinates of that point? How far do I go out? Well, I don't know. Well, actually, I do know. I could say it's half the range. And what's SY? Well, let me just go ahead and work out SY because I have enough information now because I have the time it takes to reach the maximum height. So I could say SY is capital H. It is the maximum height. So let me write down my formula again. Here's my formula. I've already written it down. SY is H. UI is 12.5 root 3. by time, which is 2.21 seconds, plus a half y. Half ay is minus 4.9 by 2.21 squared. So here's my maximum height. So put all that into my calculator. And I get a maximum height. Hope you got the same answer. 1 decimal place, 23.9 meters. The final part of this question, a little bit tricky. You need your wits about you here. Find its velocity 1 second before landing and its direction of travel at this time. Well, I suppose when they say the word velocity, that means you've got to find magnitude and direction anyway. So once I solve velocity, I'm going to find both magnitude, speed, and the direction it makes. So we're talking about 1 second before landing. The time of flight, that's 4.42 seconds. 1 second before landing, let's say it's here. And the time to reach that point from launch would be 1 second before that, 3.42 seconds. So let me have a look at this. Well, first of all, the velocity vector. The velocity vector will be a tangent to its path or trajectory. So this here, that tangent there, that represents the velocity v at that point. Complete a rectangle around it. You know, we're dealing in x and y components, aren't we? So because I'm dealing in x and y components, I'm going to have to work out my x and y components in the v direction. And then I'm going to put them together using Pythagoras to find v. So that v is made up of an x component, vx pointing in that direction, and a y component, vy, pointing down in that direction. So v is made up of those two components. It's made up of vx and vy. And what about the angle? Well, a good angle to take would be this angle here. We call it alpha. It's the angle below the horizontal. You can see vy is pointing down, and vy will be negative because it's coming down on this side. If I was on the far side here, then vy would be positive because it would be going up. So what's vx and vy? Well, vx, we're going to use the formula v is equal to u plus at. And you know that ax is 0, so therefore vx is equal to ux. So vx equals ux, which is equal to 12.5 meters per second. Vy, well, write down your full formula, uy plus ayt. Ui is 12.5 root 3. Plus ay minus 9.8. And what's the time to reach this particular point here? It's 3.42 seconds, 1 second before landing, multiplied by 3.42. So put that into my calculator, and that will give me the velocity in the y direction 1 second before landing. And I get, say, minus 11.87. The minus means it's pointing down, minus 11.87 meters per second. So now you're looking for v, the magnitude of v. So I'm going to combine those two using Pythagoras. So if I shade in that little right angle triangle there, I can say that v squared is equal to vx squared. If that left-hand side is vy, that right-hand side is also vy. So v squared equals vx squared plus vy squared. And therefore v is the square root of vx squared plus vy squared. We talked about that before. That's equal to the square root of vx squared, 12.5 squared, plus, you can ignore the minus if you want because you're going to square it. Throw it in if you want, minus 11.87 squared. So that will give me the speed 1 second before landing. Square root of 12.5 squared plus 11.87 squared. And that equals, say, 17.2 meters per second. But because I said velocity, I also need that angle in there. So I need that angle alpha. That's important. So the angle is alpha. So I can say that tan alpha is equal to, I'm just going to take the absolute value of it. So it's the absolute value of Vy. Vy is the opposite divided by the adjacent Vx. So it's Vy divided by Vx. So therefore, alpha is the inverse tan of the absolute value of Vy, which is minus 11.87, over Vx, which is 12.5. So put that into my calculator, and that will give me the angle alpha. So shift tan, fraction. It's the absolute value, so you can ignore that minus when you put it in. 11.87 divided by 12.5, close bracket. And I get an angle of, say, 43.5 degrees. And that there, if you look at the angle, that there would be below the horizontal. So you'll say 43.5 degrees below the horizontal. You've got to specify what's the angle in relation to. So therefore now the full velocity is 1 second before landing. It's moving at a speed of 17.2 meters per second at 43.5 degrees below the horizontal. That's a nice part to that question. All right, let's move on to example 6. The last example in this lesson, slightly unusual one. So a particle is projected from a point on horizontal ground with a speed u at an angle of 30 degrees to the horizontal. We're talking here about firing it off level ground and landing on level ground. The particle is at a height of 7.35 meters above the horizontal at 2 different times. Once on its way up and the next time on its way down at times t1 and t2 seconds. We're told that the difference in those 2 times is 1.5 seconds. Find the value of u. Okay, so this is a tricky little question. So what have we got? I'm firing a particle off level ground at an angle of 30 degrees. Its velocity is u. Don't know what that is. I have to find that. That's what the question is. The question is, find u. Let's have it landing here. It's 7.35 meters above the ground at 2 different times. So let's say here, that's 7.35 meters above the ground. And then if you take the maximum height and go the same distance beyond that, so this is symmetric, so also beyond here, it's also 7.35 meters. So that's 7.35, and that's 7.35 meters above the ground. And that occurs at a time called t1, at a time called t2. What they do tell me is the difference between those 2 times, t2 minus t1, that's equal to 1.5 seconds. That's the extra piece of information that I'm given that's really important. Well, let me fill my table in. Ux is u cos 30. That's root 3 on 2. So that's root 3 on 2 u. So ux is root 3 on 2u. Uy is u sine 30. Sine 30 is a half or 0.5. So that's 0.5u. Ax is 0. Ay is minus 9.8. What's Sx, the distance? Well, Sx has two different values, so kind of ignore that. What's Sy? Sy for each of them is plus 7.35 meters above the ground. So I'm going to start here. Now, I don't know u, but I do know the difference in the two times is 1.5 seconds. So I'll talk through it as I go through the question. I'll talk about my strategy. But I'm going to write down my main formula, which is S is equal to ut plus a half at squared. And I'm going to apply that in the y direction. All the y's. So what's Sy? 7.35. You're going to get a quadratic in t. You're going to get two different times because you can see there's two different times that the missile is at a height of 7.35 meters above the ground. Ui is 0.5u by t. A half ay is minus 4.9 t squared. Right, I'm going to solve that for t using my quadratic formula. There will be u in my answer, and then I'm going to have to use this extra information here to find u. So bring everything to the left-hand side. So I'll do this a little bit more slowly because it's a little bit trickier because of that u. Your ABC, your A is the coefficient of t squared, which is 4.9. Your B is the coefficient of t, which is minus 0.5u. And C is your constant, which is 7.35. So now let me apply my quadratic formula. T is equal to minus B, which is plus 0.5u. Plus or minus, we're going to get two answers here. So we've got to use the plus and minus ones. The square root of b squared, that's minus 0.5u squared, minus 4 times a, 4.9, by c, 7.35. So the square root of all of that. All over 2 times a. I can work that out, can't I? 2 times 4.9 is 9.8. So there are my two answers for t, the plus and minus one. Let me do a little bit of tidying up here. So t is equal to 0.5u plus or minus the square root of. Square that, and you get 0.25 u squared. Let me tidy up all that stuff there, see what it amounts to. So I have 4 by 4.9 by 7.35. And that gives me 144 minus 144.06 all over 9.8. So there the two times, the plus and minus ones are in there. So let me continue this calculation on this board here. I'm going to write down T1 and T2. T1, that's the earlier time. T1 is 0.5u. At the earlier time, we'll have the minus 1 in it. That'll be the smaller number, minus the square root of. I'm just going to write down the square root of. I'm not going to write down all the stuff inside it for now. That's all the stuff inside it. Just a pain to keep on writing it down. Obviously, when you're doing this in the exam, you'll write everything out. Divided by 9.8. And T2, the second time, that's the later time. That's using the positive. So it's going to be 0.5u plus the square root of all over 9.8. Now, you're told this important piece of extra information. You're told that the difference in the times, T2 minus T1, is equal to 1.5 seconds. They're going to take away these two, T2 minus T1. So T2 minus T1 is equal to that fraction minus that fraction. They're both over 9.8, so the whole lot will be over 9.8. So it's going to be T2, which is 0.5u, plus the square root, minus T1, which is minus 0.5u, minus minus is plus the square root. So the 0.5u's cancel. So I've got two square roots on top. So that's equal to 2 times square root all over 9.8. And that's equal to 2 into 9.8 is 4.9 on the bottom. So that's square root over 4.9. And of course, you're told that the difference in those two times, that's equal to 1.5 seconds. That's equal to 1.5 seconds. So now, okay, I'm ready to now fill in my square root stuff. So the square root of, what's inside the square root? 0.25u squared minus 144.06. And that's equal to, well, it's equal to, slide the 4.9 up there. So it's 4.9. Multiplied by 1.5. And I get an answer of 7.35. That number actually looks familiar. I've kind of seen that before. That was the actual heights, wasn't it? Now I want to solve that for you. So square both sides, and the square root disappears. So 0.25u squared minus 144.06 is 7.35 squared. And that is equal to 54.0225. So I'm getting close now. So now I'm going to solve that for u squared. Okay, so jump that number across and add it on. Divide by the 0.25. So I've got u squared is equal to 54.0225 plus 144.06. And then I'm going to divide that answer by 0.25. And I get an answer of 792.33. And then finally, u is the square root of that number. The square root of that number gives me an answer of, say, 28.15 or 28.2 meters per second. So nice question. But actually, the applied maths part of it was really just at the beginning. The rest of it was how good is your algebra? And your algebra has to be really good when you do these. Okay, so there are 6 nice examples that I did in lesson 1. So they give you a great founding. So that's the end of lesson 1.